Good morning, students. Last time we have started chemical properties of amines, in which last property we have seen that reaction of amines with nitrous acid, in which formation of diazonium salt takes place. When aniline undergo reaction with nitrous acid in presence of sodium nitrite and concentrated HCl at lower temperature, that is 273 Kelvin to 278 Kelvin, then formation of aryl diazonium salt takes place, in which we have seen the chemical properties of aryl diazonium salt. By using aryl diazonium salt, we can prepare haloarenes or phenols or nitrobenzene, etc. Then we have seen the coupling reaction of this aryl diazonium salt with aniline and phenol, in which formation of colored dyes takes place. Now we are going to see next chemical property of amine is reaction of amines with benzene sulfonyl chloride. Now this benzene sulfonyl chloride or C6H5SO2Cl is called as Hindenburg's reagent, and this reaction is known as Hindenburg's test. Now this reaction or this test is used to differentiate primary, secondary and tertiary amines from each other. Now here we are going to see the reaction of this Hindenburg's reagent or benzene sulfonyl chloride with primary amines, secondary amines. Now look here. First we are going to see reaction of this arene sulfonyl chloride or benzene sulfonyl chloride, or this is Hindenburg's reagent with primary amine. Now it is ethylamine. It is primary amine, and here this is Hindenburg's reagent or benzene sulfonyl chloride or arene sulfonyl chloride. This is benzene sulfonyl chloride. Now when this benzene sulfonyl chloride is treated with ethylamine, then here removal of this HCl takes place, and this chlorine is substituted by this C2H5NH group. That is here formation of this compound plus HCl takes place. Now name of this compound is N-ethyl benzene sulfonyl amide. Formation of N-ethyl benzene sulfonyl amide takes place. Now here this hydrogen atom which is attached to nitrogen atom is attached to SO2 group. Now this SO2 group is electron withdrawing group, and therefore electrons can transfer towards this SO2 group, and this hydrogen atom becomes more acidic. Since this nitrogen atom is bonded to SO2 group or C6H5SO2 group, this hydrogen atom is more acidic in nature, and therefore when this N-ethyl benzene sulfonyl amide is dissolved in base or KOH, then it is soluble in KOH. That is, this compound N-ethyl benzene sulfonyl amide is acidic in nature, and therefore it can dissolve in base like KOH or NaOH. Now we are going to see next reaction. That is, this reaction is with primary amine. That is, this Hindenburg's test or reaction of Hindenburg's reagent or benzene sulfonyl chloride with primary amine, in which formation of N-ethyl benzene sulfonyl amide, which is soluble in base like KOH. That is, this benzene sulfonyl amide or N-ethyl benzene sulfonyl amide is acidic in nature, and therefore it is soluble in KOH. Now this is benzene sulfonyl chloride, and this is diethylamine. This diethylamine is secondary amine. And when this Hinsberg's reagent react with this secondary amine, then here removal of this HCl takes place, and this chlorine from benzene sulfonyl chloride is substituted by this C2H5N group, that is secondary amine group, to form now this is NN diethyl benzene sulfonyl amide plus HCl. Now here this nitrogen atom, that is in NN diethyl benzene sulfonyl amide, the hydrogen atom which is bonded to nitrogen atom is absent, and therefore this compound is not acidic in nature because there is absence of a hydrogen atom which is directly attached to nitrogen atom, and therefore this compound is not acidic in nature, and therefore it is insoluble in base like KOH or NaOH. That is, this NN diethyl benzene sulfonyl amide is not acidic in nature, and therefore it is insoluble in base like KOH or NaOH. Now here we can differentiate primary and secondary amine by these two reactions. In case of this primary amine, that is ethylamine, when it react with benzene sulfonyl chloride, then here formation of an ethyl benzene sulfonyl amide. Now in this case, this hydrogen atom which is bonded to nitrogen atom is attached to this electron withdrawing group, and therefore this hydrogen atom can be easily donated to base. Therefore, this compound is acidic in nature, that is an ethyl benzene sulfonyl amide is acidic in nature, and therefore it is easily soluble in base like KOH or NaOH. And in case of secondary amine, when secondary amine or diethylamine react with benzene sulfonyl chloride, then here formation of an N-diethyl benzene sulfonyl amide takes place, which is not acidic in nature because here the hydrogen atom which is bonded to nitrogen atom is absent, and therefore it is not acidic in nature, and therefore it is insoluble in base like KOH or NaOH. When tertiary amines undergo reaction with benzene sulfonyl chloride, no reaction occurs. That is, there is no reaction takes place because in case of tertiary amines, there is absence of hydrogen atom which is directly bonded to nitrogen atom, and therefore tertiary amines does not react with Hinsberg's reagent or benzene sulfonyl chloride. From Hinsberg's reaction or Hinsberg's test, we can differentiate primary, secondary and tertiary amines from each other. Now we are going to see next chemical properties, that is electrophilic aromatic substitution of aryl amines. That is electrophilic aromatic substitution of anilines. Now we know that aromatic amines or aniline, that is in case of aniline, NH2 group is directly attached to benzene ring, and here on nitrogen atom of NH2 group there are lone pair of electrons which are conjugated with benzene ring, and therefore this NH2 group which is directly attached to benzene ring activates the benzene ring for electrophilic substitution reaction at ortho and para position. And therefore, these aromatic amines or aniline undergo electrophilic substitution reaction at ortho and para position easily. Now, first reaction we are going to see bromination. Now, this is bromination. Now, here this compound, that is C6H5NH2, is nothing but aniline. And when this aniline is treated with bromine water at room temperature, then here all the 3 hydrogen atom from this aniline, that is from 2 ortho position and 1 para position, all these 3 hydrogen atom from this aniline are replaced by Br. Therefore, we have to use here 3 molecules of Br2 and we'll get 2,4,6 tribromoaniline. Plus 3 HBr. Now this compound is 2,4,6 tribromoaniline. That is, all 3 hydrogen atom from ortho and para position of aniline are replaced by bromine to give 2,4,6 tribromoaniline. But if we have to prepare monosubstituted or monobromoaniline or parabromoaniline, then here this NH2 group is first protected by acylation. If we do not protect this NH2 group by acylation, then we'll get tri-substituted aniline, that is 2,4,6 tribromoaniline. But if we have to prepare only parabromoaniline, that is monosubstituted aniline, then here we have to protect first this NH2 group by acylation. Now we know that acetylation of amine is carried out by using acetic anhydride or by using acid chloride. Now here it is CH3COCl, acid chloride is used, and when this aniline is treated with this acetyl chloride, then here hydrogen atom, 1 hydrogen atom from alanine is replaced by this COCH3 group. That is, here we'll get NHCOCH3 plus HCl. This compound is formed. This reaction is carried out in presence of base like pyridine. If base is not used, then reversible reaction is carried out. This base neutralizes this HCl and we will get only this product. Name of this product is acetanilide. Now, when bromination is carried out, then here this acetanilide is treated with bromine water in presence of acetic acid. Then here we'll get parabromo acetanilide. We will get parabromoacetanilide. Now here ortho position is protected by this NHCOCH3 group due to steric hindrance, and thus bromination at ortho position is not carried out and we will get monobromoacetanilide. Now this monobromo or parabromoacetanilide is hydrolyzed in presence of base or in presence of acid. Both acid or base hydrolysis is carried out. Then here we'll get NH2Br plus CH3COOH. And this is parabromoaniline. That is, if we want to prepare para-bromoaniline, then here first acetylation of NH2 group of aniline is carried out, and then reaction or bromination of the acetanilide is carried out. Then we'll get para-bromoacetanilide, and this para-bromoacetanilide when undergo hydrolysis in presence of acid or base gives para-bromoaniline. Second reaction, nitration. Now here, when aniline is treated with nitrating mixture, then here formation of orthonitroaniline, paranitroaniline and metanitroaniline. That is mixture of orthonitroaniline, paranitroaniline and metanitroaniline is also obtained. Now we know that what is meant by nitrating mixture. Nitrating mixture is nothing but mixture of concentrated H2SO4 and concentrated HNO3, that is nitric acid. Now here when this aniline is treated with nitrating mixture at 288 Kelvin temperature, then here we'll get mixture of orthonitroaniline, then mixture of metanitroaniline, plus mixture of paranitroaniline. This is orthonitroaniline. This is metanitroaniline. And this is paranitroaniline. Now here, first we are going to see how this meta product is obtained, that is metanitroaniline is obtained. In presence of this acid, now we know that this NH2 group is basic in nature due to presence of a lone pair of electron on nitrogen atom. And in presence of this acid, that is concentrated HNO3 and concentrated H2SO4, this NH2 group undergo protonation to give protonated aniline. That is, this NH3 plus ion is formed, and this NH3 plus group is meta-directing. Now here we know that in this way transfer of electron takes place like this, and at meta position will get negative charge, and therefore this protonated aniline which is formed due to presence of this acid is meta-directing, and therefore will get metanitroaniline as a one product. Then we know that this NH2 group is ortho and para-directing, therefore we'll get electrophilic. Therefore electrophilic substitution takes place at ortho and para position, and therefore we'll get orthonitroaniline and paranitroaniline. Here percentage of paranitroaniline is 51%, that of metanitroaniline is 47%, and percentage of orthonitroaniline is only 2%. That is, here major product are paranitroaniline and metanitroaniline. Orthonitroaniline is a minor or minute product. This is due to steric hindrance. Here this NH2 group, which due to steric hindrance, nitration at ortho position is prohibited. And here due to formation or due to protonation of this aniline, here we will get metanitroaniline with 47% and paranitroaniline with 51%. Now we are going to see the preparation of para-nitroaniline. That is, we want to prepare only para-nitroaniline. Then here, like in case of bromination, we protected the NH2 group by acylation. Similarly, in this case also, we are going to protect this NH2 group of aniline by acetylation. Like this, first this aniline is treated with CH3COCl, that is acetyl chloride, in presence of base like pyridine. Then we'll get here NHCOCH3 plus HCl. This is acetanilide. Now this acetanilide is treated with nitrating mixture, that is concentrated HNO3 and concentrated H2SO4 at 288 Kelvin temperature. Then here hydrogen atom
from para position
is replaced by NO2 group to form para-nitroacetylene. Para-nitroacetanilide plus H2O. Then this para-nitroacetanilide is treated with base. It undergo hydrolysis in presence of acidic medium or in presence of basic medium. Then you will get here para-nitroaniline plus CH3COOH. This is para-nitroaniline. In this way, para-nitroaniline is prepared. Last electrophilic substitution reaction of aryl amine or aniline is sulfonation. Here, when aniline is treated with concentrated sulfuric acid, then here this aniline possesses NH2 group which have a lone pair of electron, and therefore it is basic in nature, and this is concentrated sulfuric acid. When reaction between this aniline and concentrated sulfuric acid is carried out, then it is acid-base reaction. This lone pair of electron get protonated by this concentrated sulfuric acid to form NH3 plus and OSO3H minus. This is anilinium hydrogen sulfate. When this anilinium hydrogen sulfate is heated at 453 Kelvin temperature to 473 Kelvin temperature, then here formation of sulfanilic acid takes place. That is here NH2 and here SO3H plus H2O. This is sulfanilic acid. Formation of sulfanilic acid takes place. In this way, when an aniline is treated with concentrated H2SO4, first formation of anilinium hydrogen sulfate takes place, and this anilinium hydrogen sulfate, when heated at 453 Kelvin to 473 Kelvin temperature, get converted into sulfanilic acid. This sulfanilic acid can be exist in the salt like this. This is sulfanilic acid. This sulfanilic acid can be converted into salt because in this sulfanilic acid there is presence of one NH2 group, that is basic group, and one acidic group, that is SO3H group. This SO3H group is acidic and this NH2 group is basic, and therefore in sulfanilic acid both acidic and basic group are present, and therefore it can be exist in the form of salt, that is this lone pair of electron get protonated by this SO3H group to form NH3 plus and SO3 minus ion. Now in this salt or salt of sulfanilic acid is called as Zwitter ion, or it is also named as dipolar ion. This Zwitter ion or dipolar ion is formed due to presence of acidic and basic group in the same molecule. Here we have completed our topic number 13, that is amines. Thank you.
These are the questions for your homework. Can aniline react with a Lewis acid? Why aniline does not undergo Friedel-Crafts reaction using aluminum chloride? How will you distinguish between methylamine, dimethylamine and trimethylamine by Hinsberg's test?